What is up, guys? It's TimeForDillon back at it again with another crypto video. What is up, guys? It's TimeForDillon back at it again with another electronics tutorial. Once again, we are continuing on with our Elegoo Uno R3 most complete starter kit in the known observable universe. And in today's video, what we are doing is lesson number 13, talking all about the analog joystick module. Pretty cool little sucker this thing is here. It's just like your traditional joystick on an Xbox or PlayStation controller. So in this video, basically what we're going to do is talk about how this is a great way to add some control to your project. Of course, you guys already know that. We're going to show you exactly how to use this, so make sure you guys stay tuned until the end of this video. The components that we're going to need, of course, is our Elegoo Uno R3. We are going to need our joystick module, and then 5 of these male to female jumper wires. So without further ado, let's get started with our tutorial. Usually I show you guys me pulling it out of the box. It's pointless. You guys already know where they're at. So anyways, component introduction. So the module has 5 pins: VCC, ground, X, Y, and key. Note that the labels on yours may be slightly different, depending on where you got the module from. The thumbstick is analog and should provide more accurate readings than simple directional joystick tacks. Use some form of buttons or mechanical switches. Additionally, you can press a joystick down, just like any other controller. Rather hard on his. This one, I'd say it's right in the middle. Not as easy as like a traditional Xbox or PlayStation joystick, but still pretty easy to press down. And that basically activates a press to select button. So we have to use analog Arduino pins to read the data from the XY pins, and a digital pin to read from the button. Pretty cool. So far in our tutorials, we've only used digital pins. We have not used analog yet, so this will be the first time that we're using that side of the rail. Pretty cool. So the key pin is connected to ground when the joystick is pressed down and is floating otherwise. To get stable readings from the key select pin, it needs to be connected to VCC via a pull-up resistor. The built-in resistors on the Arduino digital pins can be used. For a tutorial on how to activate the pull-up resistors and pins, configure as inputs. Pretty cool. So this is how we're going to wire this thing up. So we as you guys can tell, our pins look a little bit different than the wiring diagram on this guy's joystick, but it shouldn't be too difficult. Basically, we have the horizontal and vertical pins on our joystick going into A0 for the vertical and A1 for the horizontal. Then we have the select button going into D2, the digital 2 pin, the ground going into ground, and then the VCC going into the 5-volt pin. Pretty simple. This is exactly what it's going to look like for us. So let's jump on over to our other view and get started with this sucker. Boom. So now if you guys can see, I don't know if you guys can pick that up, everything is nicely labeled. So we have our ground, our 5-volt, our X, our Y, and our SW, which is the select button or the switch. So we could just wire it up accordingly. So for the ground, right, the top one, which is ground, I'm going to be putting in the black cable. The VCC, or the 5-volt, I'm going to be putting red. X and Y, I will be putting in brown, blue, and of course for the last one I'll use white. But the colors really don't matter. Just remember how you guys are setting it up, because that's really all that matters. So this is how I have it set up for me. You guys can see ground is black, 5-volt is red, X is brown, Y is blue, and the S, or the select, is white. So when we go to wire this up, we gotta put our black, you guys can see our black goes into the ground, boom. Our red will go into the 5-volt, which is right next to the ground. Bingo bango, bingo bango. We have our brown, which is our X. And for our X, we are going to put that into pin number A0. We're going to put our blue cable, which is the Y, into A1. Boom. And then, of course, like we said, the switch will go into this 2 pin. So when you're all set, it should look like that. Boom. Got our things wired appropriately, and of course, our switch on the other side. So let's plug this sucker in, and I already know what I'm wanting to implement our joystick with. You guys have watched my last couple videos. Boom. Alright, so we've connected everything. Now what we need to do is, of course, open up lesson number 13 in our IDE. So, just like I always say, just navigate to wherever you put your Elegoo PDF. Either you got it from the CD or you got it from the website. Wherever that folder is, just navigate to that. We're on lesson 13, so we can open up the only sketch file that is in lesson number 13. As you guys can tell, this code is very simple. Very, very, very simple. So let's go ahead and run this. Boom. And it looks like it does have a little bit of a description over here. It says, analog joysticks are basically potentiometers, so they return analog values. When the joystick is in the resting position or middle, it should return a value of about 512. The range values go from 0 to 1024. So 512 is right in the middle. If you move it to the left, it probably goes to 0. If you move to the right, it probably goes to 1024. Same thing with forward and back. Pretty cool. This is what the serial monitor will look like once we run it, and it looks like we have a little bit of a problem. You always got to make sure that you come in here. Oh, something's wrong. Let's try doing that again. Boom, we got our Arduino selected. Cool, let's run it now. It should work now. There we go. So it does work. It is compiled. It's done uploading. Open up the serial monitor, and let's go ahead and move this thing around. So, as you guys can see, right now it's just sitting there. It's not really changing anything. Boom. So when we press it forward, X goes to, so I guess it's supposed to go like this. This will be the X, go to 0. X goes to 1024. And then Y goes to 0. Y goes to 1024. Pretty cool. Now when we click in the button, switch will probably change to 0. Yeah, switch changes to 0. Pretty cool. I like the way this works. So the first thing I want to do is I want to change this delay to just maybe 1/10 of a second. Boom. That way it's constantly changing every 1/10 of a second. Because the faster we're able to change this data, the more accurate it's, or more, the less latency, essentially. So when we move this, now you guys can see, you can see it kind of zipping by, but you can still see the numbers changing. Right now it's right in the middle. Press the button, you see it change to 0. Boom, move to the left. X goes to 0. X goes back to 1023. Press it forward, Y goes to 0, back, Y goes to 1023. Pretty cool. So the way this thing works, right, if we look at the code, very simple, just like we always do. We set the pin variables at the top. You really don't have to. You could just hard wire or hard code the pin number in here. But it's good practice to make the variables at the top. In the setup, all we're doing is we're setting the pin mode for the SW pin, which is that select pin, which is essentially when you press this sucker down. That's the SW pin. And we're changing the pin mode to input. And then what are we doing? We're digital right SW pin. So we're basically turning it on. High means on, like we've seen numerous times. And that is why when it is just sitting and it's resting, you guys can see, that's why when it's sitting and it's resting, the switch is on 1, not 0. Because when we initialize the setup function, we're setting the voltage to high, which is turning it on, which is a 1. Now when we get down here and we serial print switch, this is essentially, we're saying the switch, which is the button, right? So when we press this, it's going to digital read whatever the pin is at. That's why while it's looping, blump. It's printing out all this code. Blump, 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 printing it all out. Blump, and it's on 1 because it's on high. If we press it, my guess is there's probably like a break of a connection, kind of like a switch in there. So when we press it, bump, it turns the voltage to low, which turns it to off. And that's why when we do a digital read from that pin, when we're holding it down, it's set to 0. Okay, so the x-axis is doing an analog read from the X pin. So it's kind of different than this digital write. We don't need to run a function because it's a potentiometer, and we haven't even seen these yet, but potentiometer is kind of like a dial that you turn. It could either be at 0 or maximum, and in this case 0 happens to be all the way to the left for the X, and maximum is all the way to the right. And same with the Y. Forward is 0 and back is maximum. So we don't need to do any type of digital write or analog write. There is none of that because it's mechanically done. Pretty cool. So that's why when we run these lines of code, right, the analog read, we're not doing any type of writing or anything. It's pretty cool. Pretty simple code. Not too hard to understand. There's no functions we need to look at. This is actually really simple. A lot more simple than I thought it was going to be, so I'm pleasantly surprised. So I can already think what I want to implement this with. Our radar system, like I've talked about before. Our little radar system that we did, if you guys remember the tutorial that I showed you guys. What we could do with this device is, now the Y values won't really do anything unless maybe we can have that change the range of our radar system. But our X values can change the rotation. Right? If we press to the right, it'll rotate. If we press to the left, it'll rotate. However, the only thing that we could do, I think, is have it so that when the x-axis is sitting at 5.0, see, it seems to change a little bit. It seems to be like a dead zone. So the way we could do it is have when it's around 503 plus or minus 2, it won't be changing at all. If we move to the right, the smaller the change, right? See how it's 591, 589, oh, now it's 670, oh, now it's 740. The further away from that 0 or the 502, the 504, whatever, the faster it'll rotate to the right until it hits the maximum. And it's same thing with the other direction. When we push it this way, just a little bit, it just goes a little bit. If you push it fast, it'll go fast. So that's what I'm thinking about doing with the radar. Let me know what you guys think down below. That's all I have for you guys today. If you guys made it this far, you guys are awesome. Smash that like button. Drop a comment down below. See you guys in the next one.